So we're going to look at 11D today, and this first video is going to be just your definitions of all of the terms. So a frequency table is a way to organize and display quantitative discrete data. So quantitative meaning numbers, discrete meaning it is very concrete, like one, two, three. It's not a range. You're not a measurement essentially. The frequency is going to be the number of times that value occurs. So, how many times does the number two show up? And then your relative frequency is essentially the frequency divided by the total number of recorded values. So, really, your relative frequency is your probability. Like, what is the probability of getting a two in that particular problem? And so, it would be your number of times the two shows up out of your total number of times that you had recorded the values. Okay, so then quantitative discrete data, the way to display it is going to be once you have your table, it's going to be in a column graph. And a couple things that you need to know: the range of the data values is always on your horizontal axis, so your x axis. The frequency of your data values is on the vertical axis, so it's your y axis. And then when you draw the actual column graph, you have to have gaps between the columns. So histogram is when they're touching each other, your column graphs is when they're not. And then describing the distribution of the data set. So there's three different ways you could describe it. Symmetrical distribution means that it is pretty much the same on both sides. A negatively skewed distribution is when your tail of your graph, so if you look here, here's my tail. Whoops. Here's the tail of it, and that tail is going in the negative direction. So the bulk of your data is on the right side. And so this would be a negatively skewed distribution. And then the opposite of that is your positively skewed distribution. And that's when your tail, which is right here, is going in the positive direction. So that means the bulk of your data is going to be over here on the left side. So let's look at just an example here. Another definition there: an outlier is going to obviously be something that is much larger or much smaller than the rest of the data. So you can see that here's a big chunk of the data, and then I have this 13 over here that is far away from everything else. So this would be considered your outlier. But this would be an example. Here's the number of peas in a pod. So you have two, three, four, five, six, seven, eight, nine, and then we had one pea pod that had 13, which is very unusual actually. Um, and then your frequencies, the number of times that it happened is over here. So a two is happening around two or three times. A three is about 11. A four is showed up like 18 or 19 times um, as you counted. So when you're talking about the total recorded, you're going to have to add that together. So, like your 3 plus 11 plus 19 plus 29 plus 51 plus 25 plus, what is that, around 15 plus 1 plus 1. And when you add all of those together, that's your total recorded values. So those are your definitions and your terms. So pause the video as needed, go back, but make sure you get all of those in your notes.